Welcome to the last unit in probability for this chapter anyway. You actually have a whole other chapter with probability, so I hope you don't hate it totally yet. I am going to say something about this lesson. This is, in my opinion, the hardest lesson that we've done probably so far this year, okay? I'm also going to level with you and say that sometimes I even struggle with these problems. Sometimes I have to go look at solutions and then realize, oh, that's how it's done. All right? So as you go through this and you're fighting with problems and you're not sure what to use, just understand that these are not easy problems. They're not meant to be. Okay? So without further ado, let's move on to our section. All right. I also want you to realize that these problems all kind of are lumped up in the same group. So they're not always, the practice problem is not always going to look just like or even close to the problem before it, okay? It's all about applying probability to counting rules. So it's just kind of like, the book almost approaches it as, well, you know probability and you know counting rules, you should know how to do this, okay? So it doesn't say, well, this one looks like this and this one looks like that, because there really are so many different types of problems that we could end up with. So just be aware of that, all right? So the conceptual idea behind this is that, you know, we can combine the probability rules and the counting rules and create new problems and create new solutions. So that's what we're going to do. And we're just going to work through examples. So the parent-teacher committee consists of 4 people. It's formed from 20 parents and 5 teachers. Find the probability that the committee will consist of 3 people. Of these, find the probability that the committee will consist of these people. Okay, and then A says that the committee will be all teachers. Okay, so if you have these people sitting out here, what's the probability that you will select all teachers? So these are, probability, remember, is the possibility of the events happening over the total number of possibilities. So realize that there's like a massive number of possibilities here. So first, if we have 20 people. Okay, I just realized I did my notes wrong. Okay. So there's 25 people total. And we want to know what's the probability that they will all be teachers. Okay? So there's 25. I'm going to have to grab my calculator because I did this wrong. Okay, we have 25 people total, and we're going to choose 4 people. So how many different ways can we take 4 people from 25 people? And I got to grab my calculator. Give me 2 seconds. Alright, so 25 people, and we're going to choose, so I need to do this in my calculator, probability NCRs. I'm going to choose 4 people. So that's my total number of possibilities. I have 12,650 possibilities, the number of people that I can choose. Alright, so I have 25 people total, I'm going to choose 4 of them. And what's the probability that I choose all teachers? Okay, so what's the number of ways that I can choose all teachers? Well, I only have 5 teachers, and I'm going to be choosing 4. Okay, so if I only have 5 teachers and I'm going to be choosing 4, there's only one way that I can do that. Okay, so I don't think that's right. No, right. I'm like, no, there's more than that. Okay. But where my brain was when I'm taking these notes, this will be fun for the video. But I have 5 possibilities for different ways that I can choose 4 people. So there's my probability that my group will be all teachers. Now what's the probability that my group will have 2 teachers and 2 parents? Alright, so again, on the bottom, I'm still choosing from 25 people. Okay, my total number of possibilities has not changed. So, but my top now is different. Okay, so 2 teachers and 2 parents, and remember now we're dealing with the word and, we're dealing with probability, so this is going to be a multiplication. We're going to multiply these 2 possibilities together. So 2 teachers is 5C2, and the 2 parents is 20C2, because I'm choosing 2 parents from the 20 that I have total. And again, my notes are wrong. because somehow in here I decided that we had 20 people and not 25. So I'm going to go 5, C2, and we're going to get a number, and then I'm going to go 20, C2, I have 10, and 190. I'm going to multiply those together. I end up with 1,900 over 12,650. So that is the possibility that I will get exactly 2 teachers and 2 parents. So, all right, so you see how this is complicated. Like, we have to build these rules in together, all right? So here's your practice problem. It says, find the probability of getting 4 aces when 5 cards are drawn from an ordinary deck of cards. Remember, on the bottom, you want the total number of possibilities. On the top, you want the possibility of getting that. All right? So here's your solution. Okay? If you had to look at your solution, that's fine. Okay, these are complex problems, and they're not going to be built just like the ones right before it. Okay? All right. Example number 2. So this one actually has more than one question in it as well. It says, the composition of a Senate of the 107th District Congress. Okay, so this is Congress in the United States. And this is political stuff in the United States, so I know that you probably are not totally familiar with it. But basically we have 2 parties. They are very separate in what they believe, okay? So, and then we have people that are independent that say, I don't have a party. I just choose my own values. So there's 100 senators in the Senate. So 49 of them are Republicans, 1 is independent, and 50 is Democrats. At this given time, the 107th Congress, I don't know what it is right now. So a new committee is being formed to study ways of to benefit the arts and education. If 3 senators are selected at random to head the committee, what is the probability that they will all be Republicans? What is the probability that they will all be Democrats? And what is the probability that there will be 1 from each party? So it's fairly easy to actually do the first 2. So let's look at if they're all Republicans. So, they're Democrats. Republicans first? Republicans. So we have 49 Republicans, and we're going to choose 3 of them. Over, we have 100 senators total, and we're going to choose 3 of them. Right? That gives me 8, 4, 2, 4, 18, 40, 24, or 1, 6, 1, 700. And in this case, on a lot of these, I probably should have done on the last one too. Let's put them in decimals so we can really see what's the percentage. Okay, that fraction means nothing to me. So this is 0.1139, which is, so it's about 11% chance that we're going to get all Republicans. Now Democrats, real similar, we have 50 now. Democrats are going to choose 3 over 100, C3, we're choosing 3, right? And this is 19,600 divided by 161,700. That ends up with 0.1212, so about 12%. So it's almost exactly the same. But we could end up with all Republicans and all Democrats. Again, very low percentages, though, right? I mean, if you have a 10% chance or 11 or 12% chance of something happening, it's probably not going to happen. So what's the probability that we will have exactly 1? Right? So this is and, okay, Republican and Democrat and independent. So the probability that we will have 1 Democrat is 49C1. Okay, the probability we have 1 Republican, or sorry, the other way around. 1 Republican is 49C1, 1 Democrat is 50C1, and 1 Republican, 1 independent is 1C1. Okay, so this is the probability that I will have this one and that one and that one over my 100C3. Okay, which gives me 2450 over 16170, which gives me 0.152. So this is 1.5%. 1.5% possibility that I'll end up with exactly 1 from each party. Okay? So again, we're taking these problems and we're taking them apart and we're putting them back together with the counting rules and probability. Alright, there's your practice problem number 2. Here's your solution. Okay, example 3. Alright, so a package contains 12 resistors, 3 of which are defective. If 4 is selected, find the probability of getting no defective resistors, 1 defective resistor, or 3 defective resistors. So, first of all, how many are we choosing? Let's find what's our total number. We're choosing 4. We're choosing 4 defective resistors, or 4 resistors. Okay? Of those, 3 of them are defective. So So if we want to say that none of them are defective, we need to say, well, how many resistors are not defective? 9. So we're going to go 9C4. So we're going to choose 4 defectors, and none of them are going to be, 4 resistors, none of them are going to be defective, divided by the total number. So this is 126 over 495, which is 14 over 55. Okay, again, decimals would be better. I don't have them on here though, and I don't want to take too much time calculating this. Okay, B says 1 defective resistor. So this is probably the hardest one. So A, B. Okay, it means we want 1 defective and 3 that are not defective. That's not written there, but that's what it means. 1 defective, 3 that are not. So we're going to have 3 defective, 3C1, times 9 that are not defective. We're going to choose 3 of those, divided by 12C4. Okay, when I get that, I get 252 over 695, which is 28 over 55. Okay, and the last one, C, 3 defective resistors. So we have 3 that are defective and 1 that is not. So we have 3, means we're going to choose all 3 of them, times 9, choose 1, divided by, again, the 12C4. And now I already automatically use 1 out of. Alright, so there is our different probabilities. Obviously, the last one, the one of getting all 3 defective resistors, that has the lowest probability. If you can compare the fractions. Okay, the middle one is probably the most at this point. 1 defective and 3 that are not. Okay, practice 3. Pause, do the video. Sorry. And there's your solution. And I will see you tomorrow, and we will spend some more time working on these problems in class.